So for the past couple weeks, we've learned how to do system equations and finding their point of intersection using graphs, tables, and the substitution method. Today, we're going to be using the elimination method. And we use the elimination method when the equations are written in standard form. So when they look like ax plus by equals c. That's what we call standard form. When they look like they're in standard form, elimination method is usually the way to go. With that said, we're going to start by reading the instructions. Use the elimination method to find the point of intersection for each system of equations. Check your work by substituting x and y into each equation. So we're going to try that out for the first one. When you have two equations and we're using the elimination method, we want to eliminate one of the variables. So right now we see that 3x and 3x, positive 2y and negative 2y, and 7 and negative 1. When you want to eliminate the variables, all you're doing is just adding the two equations together. So when you add the two equations, you'll see that positive 2y and negative 2y eliminate to make 0. So that positive 2y minus 2y is equal to 0. So we're left with 3x plus 3x, which is 6x, and 7 plus negative 1, which is equal to 6. Then we divide 6 on both sides, and we get x equals 1. After we get x equals 1, we take this x value and plug it into either equation. I'll plug into the first one. So when plugging into the first equation, we have 3 times 1 plus 2y equals 7. Then we simplify. 3 plus 2y equals 7. Subtract 3 on both sides to isolate for the variable. And we get 2y equals to 4. Then we divide by 2 on both sides, and we get y is equal to 2. So our point of intersection is going to be 1, 2, because that represents our x and y coordinates. Now we need to check our work. So in order to check our work, we're going to plug x as 1 and y as 2 to both equations to see if they're true. So I'll do it at the very bottom for checking work. So we have 3 times x, which is 1, plus 2 times y, and y is 2 in this case, equals to 7. 3 times 1 is 3, 2 times 2 is 4, 3 plus 4 is 7, 7 does equal to 7, that's true. Now we're going to do similarly with the second equation, 3 times x, which is 1, minus 2 times y, which is 2, must equal to negative 1. 3 times 1 is 3, 2 times 2 is 4, so 3 minus 4. 3 minus 4 is negative 1, and negative 1 does equal negative 1. Therefore, our point of intersection, 1, 2, is correct. Let's try the second equation out. When we look at both equations, we can see that the variable that easily eliminates from each other is not going to be y, because 3y plus 6y is going to give us 9y, but it's going to be 4x minus 4x. So 4x plus negative 4x gives us 0, and 3y plus positive 6y is going to give us 9y. 33 plus negative 42 is going to be negative 9. Divide 9 on both sides, and y is equal to negative 1. Now that we solve for our y variable, we're going to plug it into either equation to solve for x. Let's try the second equation this time. So negative 4 times x, we don't know x yet, so I'll just write it as x right here, negative 4x, plus 6 times y, and y is negative 1, is going to equal to negative 42. We still have negative 4x. Positive 6 times negative 1 is going to be negative 6 equals negative 42. Now we add 6 on both sides to get variables on the left side and numbers on the right side. And we're left with negative 4x equals to negative 42 plus 6, which is negative 36. Divide by negative 4 on both sides, and we get x is equal to positive 9. Negative 36 divided by negative 4 is positive 9. So our point of intersection, what we believe to be true, is going to be x, which is 9, and y, which is negative 1. We're going to verify to see if this is true. So for our second problem, write down the first equation, 4 times x, which is 9, plus 3 times y, which is negative 1, equals to 33. 4 times 9 is 36. 3 times negative 1 is negative 3. 36 minus 3 is 33, which does equal to 33. So that's true. Now we try our second equation, negative 4x plus 6y equals negative 42. So negative 4 times x, which is 9, plus 6y, so plus 6 times negative 1, must equal to negative 42. Negative 4 times 9 is negative 36. 6 times negative 1 is going to be negative 6. That must equal to negative 42. Then we have negative 6 minus 6 is negative 42, which equals negative 42. That's true. So this is actually a point of intersection. Now for the third problem, sometimes the x's and y's don't immediately eliminate themselves. When they don't immediately eliminate themselves, we want to multiply one or both the equations so that we can eliminate the variable. So 5 and 2, it's a little tricky, but positive 3 and negative 9, they're common factors of each other. So what we can do is try to make both of them into 9. One positive 9 and the other negative 9, so that they can eliminate each other. So to do that, we're going to multiply the first equation by positive 3. And our new equation is going to be 3 times 5x, which is 15x, 3 times 3y, which is 9y, and 3 times negative 6 equals to negative 18. Very important that you distribute the 3 to both the x, the y, and the answer. So all 3 terms. And we still have the same bottom equation, which is 2x minus 9y equals 18. Notice how positive 9y and negative 9y easily eliminate each other since we multiplied the first equation by 3. So it makes our life a little easier. We have 15x plus 2x, which equals 17x. Negative 18 plus 18 is going to be equal to 0. Divide 17 on both sides, and we're going to get x is equal to 0. Now that we have that, we're going to plug in 0 into either equation. Let's plug it into the first equation. So we have 5 times x, which is 0 in this case, plus 3y equals negative 6. Then we have 5 times 0 is 0, plus 3y equals negative 6. 3y equals negative 6, divide by 3, and y equals negative 2. So our point of intersection is going to be 0, comma, negative 2. Let's check to see if that answer is correct. So our third problem, 5 times x, x in this case is 0, plus 3y, so y is negative 2, equals to negative 6. And our second equation is 2 times x, which is 0, minus 9 times y, which is negative 2, equals to 18. Okay, so 5 times 0 is 0, plus 3 times negative 2 is minus 6, equals negative 6. Negative 6 does equal to negative 6. And then for our second equation, 2 times 0 is 0. Negative 9 times negative 2 is positive 18, equals to 18. And 18 does equal to 18, so that's true. So yep, that equation works for number 3. Lastly, we'll notice that in this equation right here, both equations, there's nothing that we can do right now where they'll eliminate each other out right now. So we'll need to, let's say we want to get rid of our x's. We're going to have to multiply one of the equations by a negative and the other one by a positive so that they can make 0. So 3x times negative 4 and 4x times positive 3. So negative 4 times 3x is going to give you negative 12x. Negative 4 times 2y is negative 8y. Negative 4 times 11 is negative 44. And then for our second equation, 3 times 4x is 12x. 3 times 3y is 9y. And 3 times 14 is 42. So in this case, for elimination, we had to multiply both equations instead of one equation. Okay. So now we simplify. Negative 12x plus positive 12x is going to make 0. Negative 8y plus 9y is going to give us 1y. And negative 44 plus 42 is going to give us negative 2. So y equals to negative 2. And then we plug it into, let's say, the second equation. 4x plus 3 times y, which is negative 2, equals to 14. 4x plus 3 times negative 2 is minus 6, equals to 14. And then add 6 on both sides. You get 4x is equal to 14 plus 6 is 20. Divide by 4. And we're saying x is equal to 20 divided by 4 is 5. So we're saying our point of intersection for the fourth problem is going to be 5, comma, negative 2, x, comma, y. Okay, we're going to check that very quickly with our equations being 3x plus 2y equals 11. So 3 times x, which is 5, plus 2 times y, which is negative 2, equals to 11. 3 times 5 is 15. 2 times negative 2 is negative 4. 15 minus 4 is 11, which equals 11. And our second equation is 4 times x, which is 5, plus 3 times y, which is negative 2, equals to 14. 4 times 5 is 20. 3 times negative 2 is negative 6. 20 minus 6 is 14. 14 does equal 14.